So the second look that we're going to take at square root functions. We've got a graph of y equals negative 2 times the square root of x plus 1 plus 3. So we've not only got horizontal and vertical translations, but the added complexity of vertical dilation as well as reflection in the x-axis. So we start again with our parent curve. The shape doesn't change. We put it here just for reference so that as we're working, we have it to look back at. Paying special attention to spacing. Dilation is going to affect the vertical spacing, and reflection is going to affect the direction that we move vertically. It's going to flip the graph over. Taking those translations into account first, we're going to move left 1, we're going to move up 3. So my new endpoint, what used to be 0, 0, turns out to be the point negative 1, 3. Now, from there, I need to look at the other transformations. I'm going to stretch by a factor of 2, and I'm going to reflect in the x-axis. When we talk about spacing, those purple and blue arrows, the purple arrows, I go to the right 1 and up 1. Blue, I go to the right 4 and up 2. The up 1 and up 2 are going to be affected most directly by that dilation. So here we go. We start with actually making these things move. If I go to the right 1 and down 2, why 2? Because I stretched by a factor of 2, and I used to move 1 unit vertically to find the next nice point. And we plot that point. Now I'll do the same thing with the blue arrows. I'm still going to go to the right 4. Nothing has affected my horizontal shape. But instead of 2, I'm going to go down 2 times 2, or 4 units. Again, doubling the spacing because of the stretch, moving down rather than up because of the reflection. These 3 points allow me to draw my smooth curve, and we'll talk about domain and range. Domain is left and right. Domain is input values. It's x values. If I look again at that endpoint, negative 1 is the boundary in the x direction, in the horizontal direction, and we go right from there. So negative 1 will be the lower boundary for my domain, and I'll move to infinity from that point. When we think about range, we're thinking vertical. 3 is the vertical boundary for this graph. No part of the graph appears above that value. It's the upper boundary, so it should appear on the right side of my interval. Now, on the left side of my interval is going to be negative infinity because the graph goes down forever.